Hello everyone, welcome to our pre-calculus pre-recording video. We are starting actually a new thing here, introduction to rational functions, and we will discuss the asymptotes in this lesson. So let's look at the agenda. We have the definition of a rational function, how to find out the domain of rational function, asymptote, vertical, horizontal, and oblique. This kind of thing we will have to find it out. So let's have a look. First of all, what is a rational function? Let's begin with a very simple thing. What is a rational number? What is a rational number? What do you think? A rational number is some number which is in the form of fraction, like something divided by something, like 2 divided by 3. That is a rational number. Let's say 2 divided by 3, that kind of something, or 5 divided by 7, this kind of something, rational number. So the rational function will be what? Actually, the idea is same. Some function divided by some other function. This is a polynomial. This is also polynomial. Some polynomial function divided by another polynomial function. So let's say x plus 1 divided by x square minus 2. Suppose. Then this is actually a rational function. The idea is same and simple. Some polynomial divided by another polynomial function. Then it is a rational function. So we have the definition here. It comes from the word ratio. Ratio is here. Ratio means fraction. This is the definition. Some polynomial divided by another polynomial. This is rational function, but qx cannot be zero polynomial because then the whole thing gets the undefined. And so from here, which one is a rational function and not a polynomial? Pause the video and see which one is that. C number, right? Because only in the C number you have in the ratio form something divided by something, and it fits the condition, because let's say this one is some problem, this one is not actually a polynomial, then this is polynomial but not rational, kind of that. This is also. So only this one is rational and not a polynomial. Domain of a rational function. How do we find out the domain of a rational function? So domain will come from, domain means actually the input, as you know. What are the numbers that you can put in a function? That is the domain of that function. So the reason why we study domain is sometimes, or in many times, there are restrictions. We cannot put some numbers or set of numbers in some given function. There are restrictions. That's why we need to study the domain, because for all the function we cannot put everything. That's the problem. So in a rational function, the problem is with the denominator, because the denominator cannot be 0. The denominator cannot be 0. Cancelling the common terms does not change the domain. What does it mean? Let's say, what is the domain of this rational function? X cannot be all real number other than the x equals to minus 2, because if you write x equals to minus 2, then minus 2 plus 2, it becomes 0. So the denominator here also you will have to write minus 2 whole square. So this becomes 0. So basically here it becomes undefined. So that's why this value cannot be, we cannot take minus 2 for x. So all real number is possible other than that minus 2. But what happens, this line, what does it mean? We are trying to explain. But what happens if you just expand it a bit? Then actually you get x plus 2, x minus 2 divided by x plus 2, x, this and this cancel out, so you get x minus 2 here. Now, you can do this, we can continue the math this way, but what about the domain now? Suppose still, what is the domain of this given function? We can do the cancellation and we can get something something different. But what is the domain of this function? Domain of the function will still be the same, like x cannot be equals to minus 2. All real number, x cannot be equals to minus 2. This is what cancelling common terms does not change the domain. We are cancelling it, but it will not change the domain. Domain will be as it is. Okay. In other words, do not find the domain from the last line after the cancellation, because in this question, this line domain is actually all real number here. X minus 2. If you just only look at x minus 2 divided by 1, domain is all real number here. So domain we will have to find out from the given original question. This is another meaning of this line. So domain is x cannot be equals to minus 2. X cannot be equals to minus 2. So what will be the domain here? Try to find it out. Just use the denominator to find out the domain. For what number of x the function becomes undefined. Give a try, pause the video, then you give a try, then we'll show you the answer here. Alright, so here x cannot be equals to 3, because if x equals to plus 3, then the function becomes undefined. X cannot be equals to plus 4 or minus 4, since there is a square here, so plus 4 minus 4 both works. Here we will have to do the middle term factoring, x square plus 8x plus 7, so it will become x square plus 7x plus x plus 7. Then you take the common and do things. Then you will see that x equals to x plus 1 and x plus 7 will come, which will give you the, let me do it. I think if I say, some of you may, doing is better. So x square plus 7x plus x plus 7. This 8x, 7x plus x, also it comes from 7 there. So you take x common, it becomes x plus 7 plus 1, then it is x plus 7. So ultimately it is x plus 7 and x plus 1. So you see, if we cannot put here minus 7, because minus 7 will make it undefined, we cannot put here minus 1. So minus 7 will make it undefined. This is how we know that. So all number, look, there is a mistake some student makes, and that is they say that they do the math correctly and they say that, oh, domain is minus 7 and minus 1, which is completely different than what we want, like the opposite of what we want. Domain actually is not minus 7 and minus 1, but all other numbers. Here also they do the math and they find, oh, this is 3, then they say, oh, domain is 3. Actually domain is not 3, but all other numbers are domain. This is like what you are finding, what cannot be the domain. You are finding that here. Yeah, this cannot be the domain. This minus 7 minus 1 cannot be the domain. And for this one, x square minus 7 minus x, you take x common, then it becomes x minus 1. That means 0 cannot be domain. Oh, you cannot see that, I think, what I'm writing there. So that means 0 cannot be the domain, and plus 1 cannot be the domain. Plus 1 cannot be the domain from this question. 0 and plus 1. And you can see it here. If you put plus 1, this is 1 square means 1 minus 1. 1 minus 1 means 0. So it cannot be. We cannot put that here. So this is how we find out the domain. Domain we find out from where? We find out from the denominator. What we do? We try to see for what value the denominator becomes 0. That we will have to exclude. Other than that, everything is good. Everything is fine. Now another big idea, asymptote. Asymptote is what? The word asym means something which means not, same or together. That means not same, not together. That is asymptote. Come close but never exactly together. That is asymptote. Something that never or that is never together, not together. What does it mean? Let me show you that. Just randomly drawn something. Suppose you draw a graph and then this graph started coming closer to this line. This is x line. So the graph started coming closer to this x line, and many times, like we feel like it should cross this line. x line. It started coming from somewhere there, then it coming closer and closer and closer to this x line. But it is not going there. It is not exactly together. Then, if some graph happens like this, the graph comes closer and closer to some line, then that line will be the asymptote for this graph. So in this math, x-axis will be the asymptote for this graph, because the graph comes closer and closer to this x-axis. That's why x-axis is the asymptote, and it can happen in the y-axis or in other places also, which we will discuss now. But the idea is this: the graph always the graph comes closer. Even in some extreme case, suppose the graph can happen like this, not exactly like this. Let me draw it. Let's say the graph comes closer, and then all of a sudden the graph is started coming closer to this x line. This is also an asymptote here. Okay. So let's look now. This is an example why it happens. How it happens. It looks like it is intersecting here or intersecting here. Actually, it is not in this case, because it is 1 by x. This is if you zoom it, then you will see that there is some gap in between. First of all, if x equals to 0, then it is undefined. That means x equals to 0 cannot be possible for this graph. Then what happens when x approaches to 0? That means if x value is smaller and smaller and smaller, what happens? If you put 0.1, then you get 10. Value is increasing. You are giving small value, value is increasing. If you give 0.01, then 1 divided by 0.01 means 100. 1 divided by 0.001 means 1000. That means if your value is small, like from here, then y value becomes bigger. You understand? Y value becomes big. This is what is happening here. Even from this side also, if you come closer and closer to this 0, then y value becomes negative, bigger negative number. This is negative 10, negative 100, negative 1000. What is happening here? Going to this negative side very fast in that direction. Here, going to the positive direction in this way. So, what is happening? Like, is it possible that for some number it will come to this side here? Answer is actually no, because no matter what you put here, 1 divided by that will give you some smaller. If you come closer and closer to the 0, more and more bigger value start coming, because number do not end, so this calculation will never end. Do you understand? That is the reason why the graph comes closer and closer, but never exactly together. You understand? Because the number will never end. You just put this number. This is 0.1, 0.01, 0.001. You can write 0.0001, 0.000001. And then you will get some bigger and bigger number. No matter what number we put here, it will keep giving us that thing. So the idea is, we will keep getting the numbers. The line will come little bit closer, but it will still, there will be a gap. There will be slight separation there in between. Okay, that's the idea of asymptote. Now since towards some vertical line, the graph is coming closer and closer, in this case, which is y-axis in this case, that's why this line is vertical asymptote, because it is coming closer to that vertical line. Then it can happen, it is happening in the horizontal line also, that will be horizontal asymptote, because the graph is coming closer and closer to this horizontal line. In this case it is x-axis, but it can be different. Yeah, that is the horizontal asymptote. This is vertical asymptote, this is horizontal asymptote. Vertical because the line is vertical, that is the reason. So for the vertical asymptote, when you approach towards some number, the graph comes closer. This is some number c. It can be 2, it can be 5, it can be -5, etc., etc. When you come closer and closer to that number, the graph actually goes either up or down. When you come closer to that number, but it never crossed that line. Okay, and for the horizontal asymptote, it comes closer and closer to that horizontal line, like y equals to 5, y equals to 2, y equals to 0, something like this, horizontal line. X equals to something means vertical line. Another new thing here is oblique asymptote. Oblique asymptote means when you start giving some other number, bigger number and bigger number for x, or a smaller and a smaller number for x, sometimes it happens that the graph comes closer and closer to some oblique, some inclined line, some line which is inclined, not horizontal, not vertical, means inclined, some inclined line. This line is the oblique asymptote. Oblique means it is actually not horizontal, not vertical, because this is vertical, this is horizontal. Okay, so what happens if the line is not there, like line is in between horizontal and vertical? Then that will be called oblique. And can the graph intersect it? In vertical case, it is no, because for vertical, that number actually makes the function undefined. So that is a straight no for the vertical case, but horizontal and oblique, there is not that restriction about that undefined condition. And we will find out. We will see them actually. You will see that kind of thing in the case. This is basically the end behavior, horizontal and oblique thing, because the end part of the graph, what it does, basically it comes closer and closer to that line. Basically, this is related to the, or you can relate it to the end behavior of the function. Then it will start making more sense. Now, how do we find out vertical asymptote? Now we'll try to find out vertical asymptote and horizontal asymptote and oblique asymptote. It is grab some coffee or tea or something like that. Okay, so vertical asymptote. Look at the vertical asymptote here. First of all, the graph is coming closer and closer to some line, which is actually 2. This question. And there is a relation here, 1 divided by x minus 2. So we can see it here actually, right? We can see it here. And if you zoom it, it looks like, oh my god, it is touching. But if you zoom it, actually these two lines is separate. Okay? So this is a proof that actually they are not touching. This is just what we are trying to say. And if you put x equals to 2 here, that means actually it is dividing by 0. So basically at that point it is undefined. So the conclusion is very simple. Conclusion is this is actually simple. We find out the vertical asymptote from the denominator. So we will get the vertical asymptote at x equals to 2. This is x minus 2. That is the reason. The definition is this, for which it becomes zero. Rational function in the lowest term will have a vertical asymptote at x equals to r if r is a real 0 of the denominator of q. So look at this important thing. This is lowest term, but in the domain that is not lowest term. This is very sensitive. I will tell you now why. So see, what was the domain? In the process of finding the domain, we said that domain of this function is x cannot be equals to 0 and x cannot be equals to 1. That was the domain. Okay, but because domain we find out from the original function, denominator mostly we look at, because denominator is gives us the restriction. So we can find out that 0 and 1 is the restriction here. But for the asymptote also, vertical asymptote also we find from the denominator. So what is the difference? This is what I am trying to clear. Make it clear. So the difference is both of them you will find from the denominator, but domain you will find from the original question, and vertical asymptote, for finding the vertical asymptote you will do the cancellation and everything. Whatever is remaining from there, you will find out the vertical asymptote. So vertical asymptote we will find from here, from x now. So for what value of x it becomes 0, basically 0, because x is there is no number with the x. So basically in this question x equals to 0 will be that I mean x value cannot be 0 here. That x value cannot be 0 here. Let me write something more. Let's say, suppose after the cancellation you have x minus 2. You have x minus 2. Then vertical asymptote will be x equals to 2. Suppose you have x into x minus 2 into x minus 3. After the cancellation you have this. Then your vertical asymptote will be x equals to 2, x equals to 3, and x equals to 0. So here you do not have any of them. You have just only x. That means vertical asymptote is at x equals to 0. Okay, this is the thing. So that is only at x equals to 0, as you can see. So what will happen, just to give you a more little concrete idea, what will happen about this x minus 1, since it gets cancelled out? What will happen? There will be in the graph there will be a hole at that point, because at x equals to 1 the graph is undefined. I mean, you cannot, from the original function you can see there will be a small hole, like there is a blank, there will be some blank there. Hole means the graph goes. Let me show you that. Hole means what? Hole means you go to this direction, suppose, then there is a hole, then the graph goes again, kind of that. Okay, that means at that point the graph is all of a sudden that point was not in the domain. Okay, so that is the hole. So the conclusion is domain we will find from the use the full function, and vertical asymptote we will find from the after the cancelling out, or from the reduced rational function. Okay, vertical asymptote. This is the difference. Do not confuse it. Then actually maybe you are doing the math right, but your answer will be like completely mixed. So this is what we said. Now we'll try to, this is in class practice, we'll try to find out the domain and vertical asymptotes for these two cases. Then we have horizontal asymptote. Horizontal asymptote, domain finding is, if you think like, oh my god, domain is hard, actually then you will see domain was very easy comparative to horizontal and oblique asymptote. Okay, so I think you got the idea. The horizontal asymptote is like a horizontal line, oblique means some line which is inclined, and vertical asymptote means straight vertical. And the end behavior, this will matter for the horizontal and oblique part, because you know how first it comes closer to that horizontal line, it actually matters here. But good news is, don't get scared by the way, good news is for horizontal and oblique asymptote also you have some easy methods, tricks, but the thing is this is a little bit like you will have to do some work to find it out in some cases. So look at what happens. There are a couple of cases that can happen for horizontal and oblique. Case 1, you will have to look at the highest power denominator and numerator. The up thing, if you forgot, the upper or top number is called numerator, the bottom number is called denominator. Okay, you will have to look at this thing. Okay, and most importantly, first of all, the power of x. If the power of m is bigger, if the power of m is bigger, that means if the down number power is bigger, x power, then our asymptote is very easy, and that is x equals to 0 always. Let me tell it with this example. What is the power of x? The power of x is 1 here. What is the power of x? Power of x is 2. So which one is big? Down number is big. If the down number power x is big, then horizontal asymptote is always x-axis. Always x-axis. You will not have to do any calculation. X-axis means y equal to 0. Another name of x-axis is y equal to 0 because at x-axis everywhere y equal to 0. At x-axis everywhere y equal to 0. Okay, and you can see the graph coming closer to this x-axis, and here also the graph coming closer to the x-axis. You can say, sir, oh, graph crossed it here, and yeah, this can happen if you start plugging in the value. But again, the graph crossed that line. Again, the graph is started coming closer to that x line. So it will happen. Do you understand? It crossed that, but again it comes back. Like it has some kind of affair, some kind of relationship. It always wants to come. They're like Romeo Juliet. They always wants to come closer. It crossed that line. They're like, okay, no, I don't like you anymore. But again, they're like, no, I like you. Then they're coming closer. The thing is that. But for some, we don't know. For some reason, maybe for some literary reason, due to literature or some extreme or some unknown reason, they never cannot meet, just like the asymptote. So they are kind of in relation, in some kind of affair. They come closer to each other. And yeah, so let's come back to this point, which is, so the case number 1 is if the power of x is bigger in the downside, then it is, as a horizontal asymptote is x-axis or y equal to 0. X-axis and y equal to 0 is same meaning, same thing. Okay, because at this line, at this point, everywhere y equal to 0. That is why it is called y equal to 0 line. This is called y equal to 0 line. And suppose this is 1. If I draw a line here at 1, then this will be called y equal to 1 line. Suppose this is 4. This value is point is 4. If I draw a line here, this line will be called y equal to 4 line. Okay. And that idea we will need in our next calculation, next concept. Oh. Now, what if your power is same? Suppose here x is square, here x is square. Same power. If the power is same, then there is a technique to find out the horizontal asymptote, and horizontal asymptote will be just this number, 3 divided by 2. So horizontal asymptote will be y equals to 3 divided by 2. That's it. If the power is same, you do not have to look at other things, other numbers. They are just here. They are just like the there is like in the movie you have some hero, then there is like side hero or some other things. They always like, or the friends of hero. They are kind of that, and they don't play too big role in the entire movie. The big role is played by the highest number term, highest power term. This highest power, that in other words, the hero and the heroine also, let's say. Or some of you will be like, oh my god, teacher, what is happening? Why you are talking about the hero always? No, why not heroine? Yeah, that's true. Basically, actually, the hero is also circle around the heroine. So heroine is the main character. Anyway, so what I said, let's recap. If the power is same, then this 3 by 2 is the asymptote. Okay, this is 3 by 2. This line is, in this case, uh, the line is coming closer and closer to this 3 by 2 number. 3 by 2 means 1.5. So kind of that. As x become very large, the top and bottom of the function grow at the same speed, so they cancel out. This is the reason actually why it happens, how it happens. Okay, and finding trick is like x square cancel out, so you have just 3 by 2. Because like what does it mean is how it grows. If the power is bigger, that means that part grows faster. Okay, that is the reason. Like what it says is this. So this is condition number 2. We discussed one condition where power is bigger in the down. If power is bigger in the down, just only x-axis. Without doing any calculation, you will see x-axis. If the power is same, then this coefficient will give us the asymptote. Okay, very good. Then the last one. This is crazy, somewhat crazy. If the power is bigger now in the numerator, what will happen? How much bigger? There is two conditions again in the power bigger, this part. One is 1 big. This is x power is 1. Here x power is 2. So how much gap? Gap is only 1. If gap is only 1, we will do the long division. So from the long division, we will get some answer. That answer will be the asymptote, and that will be oblique asymptote or slant asymptote. Because this is another straight line. 3x minus 3 is a straight line. Let me show you this division math. So x plus 1 divided by, let's write it this way, 3x square minus 2. So if you try to divide, how can we divide it? This is x, this is 3x square, so you need 3x. Then you get 3x square, and 3x into 1 means plus 3x. Then by rule we will have to subtract it. So subtraction means this sign will be changed, this and this cancel out. So this is minus 3x, this is minus 2. So what we need here to this is our minus 3x, this is our x, so we need a minus 3. Then it becomes minus 3x, then minus 3 and plus, so it is minus 3. Again, this sign will change when you subtract. This becomes plus, this and this cancel out. So plus 3 minus 2 means plus 1. This is just some remainder which you will not have to care of. We can just write the remainder this way, 1 divided by this x plus 1, because that part we cannot divide, that's why. So this answer will be our oblique asymptote. This answer will be oblique asymptote. Okay, answer will be oblique asymptote. Look at the condition once again. The power gap has to be just only 1. Here it is 1, here it is 2. So gap is only 1. So they can have only one gap. If it is not one gap, suppose if it is power 3, it is 1, then there is no asymptote here. We will say that there is no oblique asymptote. If it is 4, this is 1, there is no oblique asymptote. There is no horizontal or oblique asymptote, just simply that. We will not have to do any calculation. We will say that there is no horizontal or oblique asymptote in that case. Okay? So we have three conditions. 1, if the power is bigger in the downside, this condition. If the power, second condition is if the power is same, up and down, same. And third condition, if the up power is a little bit, let's say 2, and this is down 1, kind of that. 3 conditions. And the fourth condition is like there is no asymptote if the gap is more than 1, like 2 gap, 3 gap in the up. Up is 2, suppose up is 4, down is 1. So there is no asymptote there. Okay, that's the summary of everything. In this case, x equals to x-axis is the asymptote. In this case, the coefficient will be the asymptote. In this case, we will have to do the long division to find out the answer like this. And in this case, we will not have to do anything to find out the answer. So this is the horizontal and oblique asymptote finding. As I said, they have some couple of steps to find out. And all of these things is said here. Like the graph comes closer to that this line, as you can see. this is all like if the power is more than 2 more than 1, what actually happens actually, then it comes closer to that parabolic path. Yeah, parabolic path, because this is actually a parabola. If you do the division, it is actually a parabola. X square is a parabola, you know. So that's not asymptote. This is like how it happens. We are showing it here. The graph comes closer to that parabolic path. So this is the summary. No asymptote, we will say. If the power is 1 big, once again down here, then it is y equal to 0 or x-axis. Power is same 3 by 2. Then power is like this, above power is 1, then you do the division. Above power is more than 1 gap, no asymptote, no horizontal asymptote. This is practice for the for finding the asymptote. We can do this in class if you have a problem, or you can give a try by yourself. Polynomial long divisions, I think you already have the idea how to do this polynomial long division, because for this lesson you will need it. Okay, for not only this lesson, actually for a couple of lessons here you will need it, long division. Or so yeah, you will have to have some idea about this long division. Just we have shown something like this. So suppose if you try to do the long division here, this is x cube, x minus x square. Don't look at everything, just look at the first number and the highest power here. Just look at them and then you just continue it. So then it should happen. If some coefficient is not given, then actually you write here 0 and you write here 0, just to fill up the gap. Not necessary always, but just this looks good. Suppose here 0, here 0, here 0. It means that you fill up that gap. So this is x cube, this is 3x to the power 4. What we need here to get 3x to the power 4, so we need 3x, right? Then you multiply this and this. The method is same actually. So it will be 3x to the power 4 because you have already x cube here. Then you multiply this and this, you get minus 3x cube. Then you multiply this and this is 3x, this is 1, so it becomes plus 3x. Then we do this, we subtract it, this becomes minus, this becomes plus, this becomes minus, this and this cancel out because same number, opposite sign. This is 3x cube, so it is 3x cube here, and this is x square. We are just writing in order. This is x square, so we'll just bring it as it is, x square, then plus 3x. This is minus 3x it will be, because this number is already sign changed, minus 3x. So we have it. Yeah, so you can say, sir, 3x square, then 3x, why not? Why you have bring? Because this is just to write in order. Write in order. But if you don't write in order, math will still match, but you will have to keep track of that. Like, okay, what is happening here? What is happening there? We will have to keep track of that. Good idea is always to write it in order. Then actually always it helps. Now you have 3x cube, x square minus 3x. So what you need here to get 3x cube, you have x cube. So you need just only a 3. Then you multiply it. So you get, so we get 3x cube, 3x cube, then minus 3x squared, then plus 3. Then we just write it this way. Then this and this will be minus, this is cancel out, this is plus. So this is 3x square, this is plus 3x square, this is minus x square, that means 2x square is remaining. Then this is minus 3x, so it will just automatically come down here. It will automatically come down here, and then we have this is plus 3, so it will become minus 3. So when the power is less here, this is x cube, this is x square. When the power is less here, we will stop the math right there. Then we'll write that, okay, then up until here, then plus this this thing divided by this. So 2x squared minus 3x minus 3 divided by x cubed minus x squared plus 1. This is actually the remainder part. This is the remainder part, And this is actually the oblique asymptote in this math. Okay, this is a oblique asymptote in this math because the power gap is just only 1. Here there is no actually oblique asymptote. Here you will get a parabola if you do the division. So 3x plus 3, and then this thing is our remainder, as you can see. Same thing, same answer. And here in this case you will see that 2x squared minus 1, then some other remainder here. How do we do it? The same method, like what you need here. See what you need here. This is 2x to the power 5, this is x cubed. So basically the gap is 2x squared because 2 is not here. Or just simply you can say, sir, is there any other easy method? Easy method is this. You divide the 2x to the power 5 divided by x cubed. Then you do this cancellation. 2 is remaining. This is x5, x3, so x squared is remaining. So this thing you put here. Then you multiply this and this, so it becomes 2x squared. So this is 2x5. Then this is 2x squared minus this minus 1, so it is 2x squared minus 1, then minus 2x squared. So here you can write minus 2x. It is good to keep the track of everything. Let me write it nicely. So 2x squared, so it is minus 2x squared, minus 2x squared. So this one and this one cancel out. You have nothing here, but you have something here, so you write that first. Notice that we are not changing the sign here because this is in this above line. This is the bottom line. Bottom line sign needs to be changed. This is how it gets cancelled out. So you have plus 2x squared. Then this is 0, so don't worry. Then plus 2. Then this is x cubed. This is x. So what you need to match it? You just need nothing other than this minus sign. So minus sign is this minus 1. So if you multiply this by minus 1, it becomes minus x cubed. Then minus minus plus 1. Then you do again the what is remaining. This and this cancel out. You have 2x squared and this plus 1. Then 2 minus 1 means that is plus 1. Because this will become minus, as you know. This is become plus, this is become minus. So 2 minus 1 is 1. That's why you get this 1. That's why you get this 2x squared from this 2x squared. And x cubed minus 1 is this number. This is the polynomial long division for the rational function. This is in some degree it may look little bit this and that, but practice is needed for this kind of math. The mouse pointer is gone. Okay, so practice is actually needed for this kind of. Do a couple of practice, then you will see that you will get set for this kind of math. Yeah. So asymptote, basically this is kind of related to the end behavior, this horizontal part, as you know. So for that part, this part is actually will not play the role because the decay is bigger here, because then it actually is going closer to the, so the remainder will approach to 0 when x goes to infinity, because this number becomes bigger, then the whole thing becomes smaller, since the bigger power is down here. That is the reason. So the graph will be dominated by this term. The graph will not be dominated by this term, because if x value becomes larger, then x cube will become larger. If x cube becomes larger, then the whole function will be smaller because it is downside. Downside large number means whole function is a small number. So the graph will be dominated by this thing because this value is close to the 0. That is the reason why asymptote happens, horizontal and oblique asymptote, or why the graph comes closer to this parabola, because this part is going closer to the 0 and this part starts playing the role in the graph. This is the reason. This is the practice for our lesson. Find all the asymptote from here. And that's all for today. Thank you all. Thank you very much. Have a good day, everyone. See you all in the class. Bye-bye.